So Radek, I think the broadcast has just started, and it's time. It's 3 p.m. So I think it's time for the last check. Are we good?
I can hear you. I can see you. So I can.
So I hope you can see my
presentation.
okay, I hope you can see the presentation. So okay. So we're about to start.
Yeah.
We're just about to start. Yes. What else? Oh, so hopefully it works. Hopefully everything works. I need to disappear this. Okay. So yes, because it's this and that. So I need to change this. Change also this. Yeah. Okay. So I'll keep it this way. And yeah, I think we should start. So it's 3:01. So let's get into it. So I'll make like 5 seconds break, and then we will start. Okay.
Okay.
Okay. Great. Hello everyone, this is Luboš Pirkl from CFD Support. I would like to welcome you to the webinar where we would like to show you the new version of our simulation environment, TCAE. It's the version called 2310. And we are happy to show you what we have done, because we have spent, again, enormous time and effort, and really we did our best in the last 6 months to make everything better, so much better, and implemented a lot of new stuff and resolved a lot of issues. And in today's webinar, we would like to show you what we have, what we did, and we would like to give you a couple of reasons to think about potential collaboration. Okay, so a couple of notes. So the webinar is being recorded. So the recording will be made later publicly available on our YouTube channel. So feel free to look at the recording later. There will be a Q&A session dedicated to your questions and our answers. So feel free to ask your questions, and we will do our best to answer them. So feel free to ask about anything. We will pick the most representative questions right in the webinar and answer them in the webinar. And the specific questions and not, I would say, not very much representative questions will be answered later via emails, but you can be sure that all the questions will be answered. There will be, I would say, like these 3 parts. In the first part, it would be me. I would say general information about the software itself and general comments from whatever. And in the second part, there will be our expert Radek, who will show you a little bit more in detail what exactly have been done and how it is represented in the software itself, and how to use it, etc. And in the last part, there will be that Q&A session where we will be happy to answer your questions. So feel free to anytime during the webinar, ask your questions. We'll do our best to answer them. Okay, so this is quick information from me right in the beginning. And also let's do some technical checks. I'm not here alone, because today with me it's unbelievable, but yes, it's true. It's a PhD from nuclear physics faculty, Dr. Radek Máca. Hello, Radek.
Hello, Luboš. What a nice introduction.
Yes, it's great. Yeah. Okay, so I hope everything works. I hope you can see the first slide of the presentation, and hopefully I can hear you. So yeah, it seems we are set for the presentation. Yeah. Okay, that's great. So okay, so I suggest to switch off the cameras for a while. Maybe we can get back for the Q&A, perhaps.
Mm-hmm. Yeah.
Okay. So we are switching the cameras off, and yep. And so I'll continue with my general introduction. So okay, so yeah, the new version is here, TCAE 23.10. We are extremely proud of it, because so much work has been done, and it's definitely the way best version we ever did. It doesn't mean anything that the versions before was like a piece of crap. Of course, it's they were good, but everything is developing very quickly, and the user base is growing quickly, and new ideas and new I would say, issues are coming, and we are resolving them. And definitely the software is becoming more resilient, robust, and more productive, because this is something which is extremely productive. It helps you to get the results out of it. That's the difference from the, for example, open source, which is great things. It's for free, but it's what it is. But this really helps you to get the results out of it, and that's we are engineers, and that's our job to have the results. Okay, so let's go. So there will be a couple of other webinars. Still by the end of the year, we will have the webinars for about the centrifugal pump, CFD, FEA, FSI, and optimization in 2 weeks. In another 2 weeks, there will be external aerodynamics workflows shown in the next webinar, and perhaps the last webinar of this year will be Kaplan turbine workflow introduced in our software. So be sure that you will take an eye on it. And yep, I'll give a quick general introduction. So I guess you know that the company name is CFD Support. That's us. We are located in Prague, Czech Republic, and we are like 14 years in the market. And our main services are CFD, FEA, and FSI, optimization and acoustics, simulation, virtual simulation services, mostly connected, somehow connected to fluid dynamics and simulations of fluid dynamics. Our, I would say, flagship product is a simulation environment, which is called TCAE, and it's a comprehensive simulation environment, which we would like to show you today and show you the new features in this version. So if I should say one or two things about it, TCAE merges the benefits of commercial code, which means it has professional technical support, it has guarantees that it works, it has documentation, and it has the authority which maintains it responsibly. And the benefits of open source, there are a lot of open source pieces into it. So that means it's flexible, it's transparent, and really definitely not a black box, but something which is very transparent, and that's what we engineers like and appreciate very much. So that's the software, TCAE. In fact, it's a group of modules which can be used or not used, switched on or switched off, and it's an environment which is extremely flexible. So there are a couple of modules that can be used for meshing, for fluid dynamics simulation, for structural simulations, for acoustic simulations. It can all of that can be put in a loop, which is driven by the optimization tool, which takes care of all the stuff, and many more things are to come. What is important, the software is extremely flexible. It's up to the user how exactly to create the workflow. It can be combined with anything which is available in the market. It can be combined with other commercial codes. It can be combined with in-houses. It can be combined with other open sources, and it's definitely extremely flexible, and we are definitely here to help the users to create the workflow and run it and get the results out of it. One of the best benefits of TCAE is that for one price, there are no limitations on number of users, jobs, cores, hardware installations, and TCAE, I repeat it, for one price, it allows the users to scale the resources to the fullest. It means the users, hardware, and everything. So it's big benefit. It's accurate. It's focused on turbo machinery. It's focused on external aerodynamics. So it's definitely not a black box. It's a tool which is developed to be automated, to be focused, and it's always up to the user how deep to dive into the rabbit hole or not at all. It can be used in various ways. So it can be used as a black box if you like. If the users wish to use it as a black box, it can be used as a black box, or it can be used as a fully sophisticated software with where all the options are open. So the beauty of it is that the user decides how to use it. So that's a big point. A lot of benchmarks have been done. Some of them are available for public presentation, so feel free to take a look about them. It's on our website, or feel free to ask. We will do our best to show you what has been done. So it's been acknowledged and confirmed many times in the past. It's definitely ready to be used on laptop, desktop, normal PC or cluster or cloud. It can be used remotely from home. There are a lot of options. There are two builds developed in parallel. One native compilation for Windows, the other one is native combination for all the Linux versions, and it's really a big project and well tested and ready to be used. It's based on open source. That's a really big thing again, because as you know, here at CFD support, we have mastered the process to, I would say, using the open source and turn it into the usable usable software for the engineers to be used in the industry and to be productive for professionals in the industry. So TCAE has more than 60 open source projects to create a coherent software where everything works together and is really functional. We've spent enormous time in developing it. So all the I would say ready open source pieces have been put together, and it has taken enormous time and effort. So we are developing TCAE in team of PhDs for 10 years, and altogether if we aggregate the time, it's more than 40 many years of team development of something which seemed to be ready 10 years ago, but it's not. If you want to create a software which is resilient and robust, it definitely takes a lot of time to test everything and to really make it work. Okay, so it's based on open source, and the source code is available. So the simulation methods and everything, it's available. Anyone can look at it, and if necessary, they can be changed. So it's up to the users. So definitely very transparent and very flexible. And yeah, today we are here to introduce you to a new version, which is called 23.10. And yeah, again, we have spent a lot of time. We have put, I would say, our best. We did our best and put the best of ourselves into it. And I would, Radek, in the second part of this presentation, I'm coming to an end with my part of presentation. Radek will, in a minute, he will show more in detail the new capabilities. I would mention a couple of them just as I see it now. I think very important new feature is that it's possible to disconnect and reconnect again the graphical interface from the simulation. So you can set the simulation in the workflow in the graphical interface, run it, and then you can close the window, disconnect, and you can connect again, which is very helpful. We know it because this requirement came from our users, and we know it's a very useful function. So, for example, this is quite a big one. Well, we have added the real particles, the real particle tracking module to the simulation. So it's I would say quite important physics and physical new feature and capability included. And for example, another, yeah, there are a couple of things. Okay, maybe it's not important to mention all of them. I would also say that there's new license concept, which is another improvement to all of us, because the last license concept was not sustainable anymore. It was the Stone Age concept, which was replaced with the new one. So now the users are they actually sign into the software and use it. And so, for example, this. And yeah, a couple of things. Yeah, what is very important that there are more than 100 specific issues that have been resolved. They're not visible, but they have been resolved, and they're extremely important. So it's a paradox, but the invisible thing, which is solving a lot of bugs and issues, etc., and new software updates and their collisions and new operating system updates and everything have been resolved. So it's a paradox that the thing which is not visible, which is the maintenance of everything, has taken more than 50% of all the effort. But that's life. That's the way how the software is developed. And so it's extremely important to switch to the new version because everything is better. It's difficult to describe it, but it's I believe it will be seen in the real practice. Okay, so I'm moving a little bit farther. So this is just the beginning. This is definitely not the end. So as you know, software, such a simulation software is a living organism which is being developed, and it's getting sometimes better, sometimes it's getting in shape, sometimes it's getting sick a little bit, but altogether it's getting better and better, and we are working further. So for the future, for the next release, we will definitely be working on the TOpt module, which we believe it's a great thing, which is it's a paradigm shift. So TOpt module will be definitely further developed. Also, the acoustics module, we're working on it. I would say pretty hard, and again for the new version it will be developed even more, and new workflows will be added and new benchmarks will be added, and you can be sure that this acoustic module TCAE will be further developed. And the best of it, the best of all, the best for the last is the new module T-Base. So in the version, hopefully early next year, but let's see, there will be the new module which allow the users to create their own knowledge bases and databases, which allow data mining, machine learning, and it will allow users to create his or her own surrogate models, which is we believe perhaps the future for certain parts of virtual prototyping. It's especially for early stages. It will be really we believe that this will be disrupting technology, which will allow users to use, I would say, to design in seconds instead of hours or days. But let's see. But it's very promising. And then the new module T-Base, which allow users to mine the data. Either from simulation, measurement, and anything, it will be really huge, and we believe it's the future. Okay, so that's the future. So this is just the beginning of everything, of course. And yes, finally here he is, the one who comes after me, which is Radek. Radek, can you please take over?
Yes, I can. So just give me the floor and I can begin.
I am doing it right now, and it seems now the stage is yours. We can see your screen, so
okay, perfect. Thank you, Luboš. And I would like to say that it's my pleasure to introduce these new features, which mainly developed our colleagues, which are not seen in these webinars and these presentations. So thanks to them, we were able also to bring this new brand shiny version of TCAE. So let's start to introduct the main visible features which we altogether developed for this version. So this is the list of the features and functionalities I would like to present within this webinar. So maybe I will not go step by step. Let's say I will go step by step, but I will not mention right now and read all the parts. But it's kind of, this is the summary of all the slides which I will present and I will be talking about. So let's go for the first feature we have developed, which is this disconnect and the reconnect function or feature. So now the GUI, because in the last version, when you close the GUI under the running process, then the process behind was stopped, and then you must reopen the GUI and start from the point where it was ended. So typically you should start from the beginning or the simulation from the very beginning. So now any process or the process behind GUI is kept alive. And if you reopen the project, then the GUI automatically reconnects to this running project. So you can closing GUI, opening the GUI, and still the simulation or each part of the workflow will be running. Yeah, this also works if the process is run in the batch mode, for example. Typically in Linux machines, you run it by a script or whatever, and then, for example, where you would like to see graphically where the simulation is, then you just load the project into the GUI, everything is reconnected, and then you will see, for example, live residuals, etc. Maybe I will show you in a few seconds how it works. And because the process is locked basically to the GUI, so you cannot open two GUIs connected to the one project, but the GUI will tell you that some other instance or some other GUI is managing the running project, so it doesn't allow you to open one project in two GUIs. So for example, let's go for an example. So I have installed a brand new version a few hours ago on this machine, so let's see if it works, but it will definitely work. And let's go for it. So as you can see, the GUI looks very the same like the previous versions. Yeah, the dark mode is still here and all the setup and layout is the same. So let me load some simple examples. So I will go to the installation folder here for the basic tutorials, and for example, I will open this pipe project, which is a simple pipe shape, and the flow goes through one inlet, through the inlet to the outlet, and I think part of this project is also the FEA analysis. So when I would like to run the project and show you this connect and reconnect feature, so I simply run the simulation. So now you can see that the meshing is the mesh is generating. Now I can close the GUI. It will just tell you the message that some operation is running, and if you close, the simulation will still continue in the background. Okay, yeah, sure. This is my intention. And when I open, for example, by the GUI, or I can go on the disk. For example, I am using this free commander for the file system browser. So I will go to the TCAE again, to the tutorials, to the pipe, and by right click, I can open the project in the GUI. And now the project is loading, and also the running simulation or this thread is again loaded into the GUI. And as you can see, we are already during the simulation phase. So the mesh was done. And if I go to the manager and visualize, yeah, the this processing bars, I can see that still the simulation is running, and I can follow the simulation, visualize the intermediate results, etc. And this I can do anytime and as many times as I need. Yeah, so this is the very nice and powerful feature which we have developed. Yeah, so this opening and reopening, closing, etc. So everything continues in the process. All right, so this was the disconnect reconnect feature, which is pretty simple. So for the users, you just you give the more power to follow the running process on the background, for example, and so on. So you can close it, prepare the new project, and so on. Let's go for the next feature, which is the reset settings to the latest save. What does it mean? So it means that in the previous version there was no like undo button or something like that. So here we bring the new button discard changes. So when during the, for example, the the phase of preparation of the project, of the new project. So I do some mistake. So for example, I close accidentally one component, or I miss some data or whatever, then I can anytime click on discard changes, which will bring the setup to the latest stored or saved setup. Yeah, so how it looks. Okay, this simulation is still running, so let me for example open another project. So let me open new GUI instance. So again, the number of instances is not limited, so you can open as many GUI as you want. So let me load some additional or some different projects. So let's go for the tutorials again. So let's, for example, this Kaplan hydro turbine, and I will show you how it works. Right. So whenever the project is loaded, perfect. So I can, for example, go to the tmesh, I don't know, to the component, and because I was somehow setting up the component, so I will get rid, for example, accidentally of one component, which means I destroyed my setup. But if I didn't save the current preset, I can click this discard changes button, which will bring me back what I have done. So if I go back to the tmesh component module, after reloading all the STLs and which I have closed during the process, so change were discarded, and you can see that the component 3 is back with all the setup. Yeah, so I think it's also powerful feature which can save a lot of let's say a lot of user made mistakes during the setting up the process or the workflow. So this is the discard button, which we can find here, which is active only when some changes are made. Yeah, and this is all overloaded or override by the saving. If you save something, this is new. Let's say the checkpoint from which the discard changes can be restored. Yeah. So the reset settings, I think the pretty straightforward feature. Let's go for some another functionalities. So we have improved the cavitation risk functions. So newly you can set the custom saturated vapor pressure, which was originally automatically evaluated just for the water at the given temperature. So now you can set a custom value for the saturated water pressure, which, or not water pressure, saturated pressure basically, and this value is used afterwards to evaluate cavitation risk, which is the just cavitation field, which denotes where the pressure is below the saturated pressure, or where the values are above. So let's say this feature is very the same like the previous, but it can use the custom value. Then we have redesigned the cavitation index. So the cavitation index is evaluated in a more proper way, and we also implemented based on suggestion of one of our user. We implemented this histogram feature. So the cavitation number is based on the vapor pressure, and in the CFD field, it was evaluated by the minimum value of the pressure at the given part of the domain, typically on the rotor patches, for example. So now you can pick up on which patches this cavitation or this minimum or histogram pressure value will be evaluated. And the histogram value means that, because in the numerical simulation you can have, of course, numerical errors and some values which are really the minimum value, which some kind of are out of let's say, how to say, out of the real range of the physics, let's say. So this feature evaluates the minimum pressure as using the histogram. So it sorts all the pressure at the surface from the minimum one to the maximum one, and the first 0.5% of the surface is thrown out, and the minimum pressure of the rest is taken as the minimum pressure. Yeah, so the minimum value, 0.5% of the surface of the minimum with the minimum pressures are thrown out, and the resting minimum value is taken as this value. And we evaluated automatically this histogram based on the 0.1, 0.5, and 1%. And using the similar approach, we also evaluate the net positive suction head available, which is directly evaluated from the vapor pressure and pressure on the low side, which means for the pump it's at the inlet, for the turbines, hydro turbine, it's at the outlet. And in the similar way, the required net positive suction head is evaluated based on this histogram value on, again, on the cavitating patches which user chooses. So this is the new feature, and now it can be applied both for the pumps and both for pumps and hydro turbines. And everything is evaluated, everything is presented in the HTML report as a graphs and tabulated values, and also you can find it on the disk as the CSV values. So this was redesigned, and it's now more applicable. The next new feature, which is new physics implemented, is the transient particle tracking. So we have developed a new feature, or let's say we have enabled new solver solving for the Lagrangian particles motion, which is really the physical. This is really modeling the motion of each particle. And in the GUI now it's pretty straightforward to set up. So you just, at the moment, you just set the particle density, particle size, and at the inlet or at the more inlets, you define the injection rate. Yeah, we are planning to develop more models, different sizes, and so on. But at the moment, this is the basic setup, and it can be, by the way, extended by the scripting options. So it works like a function, so it can be added to all incompressible transient solvers. And yeah, so basically you can add it to the stator types, to the hydro turbines, pumps, etc. And additionally, it also evaluates the collision rate at the wall, so some advanced post-processing based on some distortion of the wall, or some impingement or impact rate, and so on, can be evaluated based on these values. Okay, so maybe if I can show it, for example, here. So if the model is chosen to be transient, so I will quickly switch to transient. Then if I go to the multiphysics, I can here enable the particle simulation. Then I can set the particle density, particle size, and in the boundary section at the inlet side, I can preset the particle injection rate, so particles per second, for each operating point. So it depends of what is at the inlet. Yeah, so the setup is pretty straightforward, and the evaluation is also pretty straightforward. So maybe we can show you in the next webinars how to, for example, visualize the data, but it is pretty simple, because you can see it in the resulting fields, and it can be evaluated as the particles, so you can see every particle within the domain, or at the surface you have this collision rate field, which can be visualized as it is here. So cloud collision density it is called. So it is how many impacts per meter squared was measured. So transient particle tracking, let's go for the next. Oh yeah, this is the example what you can now visualize and simulate. So this is the particle tracking inside the radial pump. So this kind of also the videos and post-processing and evaluation you can directly do with this new version of TCAE. And yeah, each particle holds its own property, like the size, like the velocity, particle velocity, and other quantities which can be visualized and used for post-processing. Okay, so let's go to the next, which is new model, turbulence model, which belongs to the DDES family of turbulence models. So here we have nice video, which is the records on LinkedIn shares, right, in CFD field, I guess. So Luboš is proud on it, right?
Absolutely. Absolutely, I am, yes.
So yeah, this basically you can now all these visualization can you directly done within this standard TCAE. So you can enable this turbulence model, preset the workflow, and visualize all these kind of fields I will present in the next slides. So this is a nice comparison of these three families of turbulence modeling. One is the standard runs, steady state runs, transient runs called U-runs, and this hybrid between U-runs and LES, which this DDS family of the models. So you can see nicely how the vortices which are resolved by each turbulence model. Okay, let's go for the next feature, which is the additional quantities evaluations. So we directly add the option to the users to evaluate these turbulence-like quantities like the vorticity, Q criterion, or turbulence intensity. And additionally, you can directly evaluate the wall shear stress for some advanced post-processing at the walls, and also the pressure coefficient CP typically denoted. So all these can be evaluated on demand. We are not going for the version that everything will be evaluated automatically, because it takes a lot of space on the disk. So therefore it is on demand. So because user typically know what he would like to evaluate from the particular simulation. So the user decides what or which values can be, or which quantities will be evaluated. And basically the previous video was also evaluated based on the vorticity. So now if you enable the vorticity magnitude, you run transient simulation, you set the time step for storing the results, and then you can generate similar simulation like this. So this is, I think, a Kaplan turbine with the transient simulation and with the vorticity magnitude visualization. Okay, so going for the next one. Yeah, this is also a new feature based on the user demand. So we have developed a new kind of boundary condition of total pressure, but at the outlet, not at the inlet. It was originally it was applied for the acceptance test of hydraulic turbines, where the total pressure is known in some closed circuit. And basically there are two variants evaluated, or two versions how the dynamic pressure is evaluated for this kind of boundary condition. So first one is called weighted by the flow rate. So this dynamic part is weighted locally by the flow rate and set to basically to have the total pressure 0 at the outlet, and or not 0 but the given one. And the other option is that it's not flow rate like averaged or weighted, but it is directly computed from the normal component of the velocity vector. So basically just the flow rate is taken at the outlet and divided divided by the area of the outlet section to have this velocity squared value. So these two options can be now set for some specific applications at the outlet. So total pressure at the outlet. For the convergence check, originally there was only relative values, which, for example, for the efficiency, relative value is basically the percentage from the percentage, right? So we have developed the absolute value, and also many of our users wanted to have these absolute tolerances. So now you can set type of the tolerance. So for example, for the efficiency, you can set that your tolerance is really 1%. For the total pressure difference, you can set 150%, not percent, 150 pascals. And for example, for power, your convergence tolerance is again the relative, which means 1% of the power which is simulated. Yeah. So then basically the convergence check stops based on your values, either absolute or relative. So typically for efficiency, your goal for the accuracy is, for example, 0.1%. So 10 times less than this. So you set up 0.001, set the absolute, and then you will get the accuracy of the, for example, of the average efficiency within the 0.1%. Then some kind of I have to say user hidden features, but which are very, very useful. One of them is the Diskspace Efficient parallel reconstruction. So what does it mean? The original reconstruction works like follows. So first, during the parallel computation, all the quantities like velocities, turbulent quantities, pressure, etc., are stored in each decomposed folder, yeah, which is associated with the given processor. And during the reconstruction, first all these fields are reconstructed into the one field basically, and after that they were erased or deleted. So it means that, for example, if the original data takes 10 gigabyte of the disk space, then during the reconstruction you need another 10 gigabytes because all the fields are first reconstructed and then deleted. So we have developed the new reconstructions, which it deletes all the files on the fly. So each file is reconstructed, then the decomposed one is deleted first, and then it's going for the next. So in this 10 gigabyte example, you will not need another 10 gigabytes required. Typically for some very fine transient simulation, when you need to store all the time step, for example, to have a fancy visualization and animation, you would need, for example, hundreds of gigabytes of data, and then it makes sense that you don't need to have another amount of the same disk space to just for the reconstruction. So now it's more effective and disk space efficient mainly for these huge cases. All right, then the next support is for the multiple inlets and outlets. So again, in the old version, for example, if you have the geometry with multiple inlets or multiple outlets, so in the old versions, these outlets were somehow merged into one, and all the fields were evaluated, and the integral values were evaluated as it is a one inlet. So typically, so you will see just two values, what is happening at the inlet and what is happening at the outlet. With the new version, if your geometry has, for example, 3 inlets, so then you will see all the values per inlet or per outlet. So you will see really more information you need to see. So for example, the flow rates, pressures, velocities at each inlet. Typically for this example, which was the manifold with 3 inlets with variable flow rates at the inlets, you really need to see what is happening at each inlet or at each outlet. So this is the new version. And for the stream paths, which will plot you the pressures, for example, through your domain from the given inlet to the given outlet. So you can not automatically, can be set by the user, and then they will be seen in the report. So multiple inlets and outlets. Also, another feature which is not visible for the user, but it's very effective and extremely wanted is the new auto-write function. So what does it mean? TCAE now, and mainly the simulation, automatically saves or writes down the intermediate results. So what does it mean? For example, if I have set simulation with a single point without any intermediate savings, and it took 1 week, and after 6 days there is an electricity shortcut or whatever happened with the computer, and the simulation stops, then you don't have any intermediate results to restart the simulation. You simply need to start from the very beginning, and you lost 6 days of computation, which means hundreds of, for example, core hours. So now the auto-write interval is set to 2 hours. So every 2 hours on the background, the intermediate results is stored. After next 2 hours, again, new intermediate results are stored, and the previous is deleted, which allows us, if anything happened, you can continue with the simulation when you reopen the case, and you lost only last 2 hours of simulation in maximum. And on the background, if you go into the case, you will see some kind of such values. For example, this is the transient case where every second is stored, but for example, every second takes I don't know, 10 hours of simulation. So then, for example, you will see something like that the folder with the value with the auto write point, and if at this point the simulation crashes, or I mean your computer crashes basically, then you can reopen the case and start from this time step and continue with the simulation. So this is very useful function. Then some visualization features. So for example, in the TFEA report, you can now visualize, you can now see the visualization of the stress analysis or the frequency analysis. So let me check if we have it for this example. So if I go for TFEA report, and yeah, I go for this static analysis. So I can see here the displacement magnitude and von Mises stresses directly in the report, or I can show it here in the render view. So these kind of visualization are now available directly in the report. So yeah, okay, let's go back to the presentation. Yeah, here. So these are the automatically generated renderings in the TFEA report. Now we are going to the TCAE report, so a report connected to the acoustic analysis. So here we bring a very, I would say, fancy feature that you can play the sound which were analyzed for the observer. Unfortunately, I'm not able to run it or to go to your side to put the sound to your side, but you can check by your own if you go to our web pages to the NACA 0012 airfoil simulation, and there is the acoustic report example. And if you go to this observer summary section, you can run the sound which were evaluated. So this is just the external flow around the NACA profile, and basically you see all the power spectral density, etc., and this signal which is then reconstructed to the sound, and you can play this sound. So we have a lot of fun at the company, at the office, with running and generating different noises and running into the into our speakers. Okay, so let's go back to my presentation, yeah, which is here. So this is the sound reconstruction, very nice feature. I really suggest to go to our web pages and try by your own to run the sound at your site. Another nice feature for the visualization point of view is the custom render view. So typically, because the HTML report originally generated some custom views, and this, or not custom views, some preset views, which were not optimal for all the cases and all the geometries. So now you can set your own custom render view. So let's give it a try. So you can set it both for FEA module and CFD modules. So if I go, for example, for CFD modules, so this is the default view. And if I would like to change the view, so I go back to the rendering. So I adjust, for example, this view. I like this view. So I go for the TCFD module for the post-processing for the report. And now I can just click select active view, and this current view will be copied and put to the report. So now I have set it. Now I need to save my setup, so my current view. And if I go to the TCFD run, you can see now that the report is outdated because I have changed the view for the render. And now I can click again the CFD report generation, the full report, and then I will see the new view what I have set. And the same I can do for the FEA report. So again, I can click the select active view here. I can click save and run the FEA report. Okay, and meanwhile, okay, the CFD report was generated, and you can see that the current render view I've set is shown in the report. And the same for the FEA. Again, yeah, the same view I've set. So using this, you can nicely adjust the view to have really nice report you need. Yeah, for example, typically for this kind of large domains with small object inside, it's really useful. Yeah, like for this proper DJI example. So I've set this view, and now you can see this view in the report. Okay, I think almost the last two features left to present. This one is the scripts file editor. So from now on, you can edit or create the scripts directly from the GUI. So if I go to some scripting section, for example, here, scripting, so I can import new script or create new script. So I will click create new script. I don't know, import, or as just, this is the Python scripting. So I will save it, my script, for example, and now it's here, and I can set the execution point where I would like to execute this script within my workflow, and anytime I can edit the script, save it, and again run it and whatever. So now you don't need to just edit it into the external editor, then import again, and so on. So you can nicely edit it within the GUI. And this holds also for example, boundary conditions. So you can create new or import. So you can create new boundary conditions, tell some, I don't know, format, time, and value. Yeah, so you can do something like this and import the time variated boundary condition for volumetric flow rate, for example. Okay, so this is very nice, also very nice feature developed in the new release. And I think this is the last one, yeah, the new license concept. So the new online license concept was developed, as Lubos already pointed, and which brings wide range of options. And it is based on the authorization based on username and the password which you give after buying license or asking for a trial license or whatever. And basically the software asks for the authorization once a month, yeah, just to authorize that you are still, it's still you who is using the software, and the authorization is pretty simple. For the first time, it will ask automatically, and if you see that, for example, the next refresh is coming, then you automatically, and you manually click authenticate, you put your username, password, and then you have again time next month to without the authorization. And the same holds if you just running it in the Linux, for example, without the GUI, then you can also authorize by the command, or it will automatically after 1 month it will ask you to again authorize the license with your username and the password. And that's basically all. So no need to download the file, put it at some proper space, proper point at the disk, and so on. So it's much comfortable to be used. And which brings me to the end of my presentation, and it's time to continue with the Q&A or with anything else.
Yes, Radek, yes, thank you very much, and especially thank you for preparing all of this, because I know how difficult it is to gather all the details and everything. So thank you for it. And yeah, let's go ahead. So I would like to ask the audience to ask your questions actually, and we'll do our best to answer them. So yeah, it's your time, so use it. We'll be happy to answer what we can. So yeah, ask your questions. Of course, if you don't have a question at the moment, doesn't matter. Of course, you can ask us anytime later via email in privacy or whatever. That's absolutely okay. So yep. So when I saw all of this, I just realized that I already received a couple of questions. So I will start with one which I received yesterday from our long-term user, which is if it makes sense to switch to the new version if the old version works well. So that's actually a very difficult question. Maybe Radek, do we switch on the cameras because
okay, yeah,
maybe it helps our gestions, you know. Yeah. Okay. So it's very sometimes it's difficult question, because we know some users, especially long-term users, don't switch immediately to the new version if when they feel there is nothing especially new which concerns their workflows, which are well automated and work, right? And we are engineers, and what matters? The results matters, right? The results matters always. So if the old version produces the results, why should we change to the new version? Which is great, and I absolutely understand. But of course, all these what we have shown, it's some of them are not concerning my project, right? So why would I care for the new version? But the message, it's the decision is of course always up to you, always up to the users. So users decide everything. So users can decide whether to switch to the new version or not. But I feel responsible to tell you that that's very important thing, that a lot of information is hidden inside. A lot of information is difficult to explain, how we deal with graphics on various systems, and how those 60 plus open sources communicate each other, and how we kill all the conflicts and everything. So sometimes it's difficult to explain everything. So generally, the new version is always so much better, because we see it every day, all those tips and all those bugs and everything. So generally the new versions are always better, but of course it's always up to the user. We are here to help, so feel free to ask, and we together definitely will make it. But I would generally recommend to rather, if you're not sure, I would generally recommend to rather switch to the new version, because there is a lot of a lot of work is hidden in it's lost in the translation. It's definitely not possible to explain everything, and it's a teamwork. We're like 7 people here working full time on this, and sometimes it's difficult to explain everything. Okay, so that's the new old version, new version. It's always up to the user, of course. And the questions. Yes, let's take a look. What I see here, Heiko. Hello, Heiko. Yeah, our old friend, and he's not old, but old friend and a long-time user. Yeah, he's asking about the licensing. If this now license server is required. I'm not sure if I understand perfectly, but all you need on your site is to have the login, the username and password that lets you in. TCAE only asks our server, just pings it whether the license is okay, and then you continue once a month, which is we believe this is the way, it's preferred way from our side to all of us, and we all do it, and it's the preferred option. There are a lot of other options, so if someone is absolutely offline for sure on confidential projects, there are options. We have also those hard copies of license files as the old system was, so no worries, there are a lot of options. We are ready for that. We are ready for extremely wide range of options what to do with license. So we're flexible in it, so don't worry about it. We'll always find a way, you can be sure. And also, again, Heiko is asking about the transient particle tracking, new physics edit. Is it possible to evaluate an aberration rate? Yes, that was originally the goal. The particle function object is huge. I admit that we don't understand it perfectly because there is a lot of physics included, but you can be sure that yes, the aberration and this where processes are that's the goal, because the particles, they can interact, they can hit each other, and they can hit the wall and they leave the track. So if certain place has been hit a lot of times, it will be there's the collision rate value, and you can see the map what places are hit often and what locations are not hit at all. So yeah, so there are some probabilities, and we're ready for that. There are a lot of options that can be added, so we're waiting for your requirements to our user bases, what you would recommend, what shall we edit, because there are a lot of options, really a lot of options. We are you can see them in the function object settings, so you can see them immediately that there are various sizes and bouncing physics and a lot of stuff. Yeah, and they can stick and everything, so it's really a big thing. I admit we do not know all the details at the moment, but we are ready to dive in it together with you, and for the next versions to add even more options to the graphical interface. And what's important, everything is possible right away via scripting. So using scripting, you can change all the options. So it's fully usable right away. And let's see how beneficial it will be, and what will be the feedback on this. Okay. Yeah, questions. I don't see many representative questions to answer at the moment.
Yeah,
so,
me neither. Yeah, me neither. And I think more than 1 hour is left, or no, not left. It's up. So
do we wrap it? Do we wrap it up?
Yeah,
are we done?
We can slowly
conclude. Okay. Anyway. Okay. Okay. Let's do that. Okay. So where am I in my presentation? I was here with this, which someone left here on this computer, and okay, this will be it. So yep, anyone is welcome to join us. It's our job and it's our pleasure, and I guess we will leave you with that. So you're welcome to come anytime. We will answer all the questions. We are here for you. Radek?
Thank you for watching. Keep safe, and we are looking for the question or whatever you will.
Yes, and for your feedback. Enjoy the new version. We're happy to be here for you, and I guess it's time to say goodbye for now. So
Okay.
bye-bye.
Goodbye.
Bye-bye. Thank you. Bye-bye.